Hi, welcome to Unit 2 for AP Physics C, dynamics, or also referred to as Newton's laws of motion. So we're going to start way at the beginning with Newton's first law. Again, like if you've taken a Physics 1 course of some kind, this stuff is not that much different. So what we're going to do is we're going to add into the backside such things as drag force. So in Physics 1, remember, we didn't account for air resistance. So in this, we're going to account for air resistance now. And we're going to look at how drag force affects it. And I mean, everything's pretty much the same as from a Physics 1 course, right? So Newton's first law. So first thing is talk about dynamics. It's the study of how forces affect the motion of objects and systems, where kinematics is just describing a motion. Dynamics is now how do we affect the motion by looking at forces? And a force is simply a push or pull on an object. Again, definition doesn't change from Physics 1 to an on-level physics course. More commonly, when we look at the forces, though, we're looking at how does the net force act on it, right? So the net force, remember, is the sum of the forces, right? So the sum of all the forces that are acting on an object is really what we're looking at here. So when we say force, a lot of times we're looking at that net force aspect. Now, Newton's first law states, a body at rest remains at rest, or in motion, or if in motion, remain in motion at constant velocity, unless acted upon by a net external force. And I forgot the quotation, right? So the main thing is for you to do anything, for the object to change its state of motion, something has to come from the outside. Okay. Now, the first law is referred to one of two ways, right? First thing, we call it the law of equilibrium. What that means is the sum of the forces acting on the object is going to be zero. And the way we look at it, there's two states of equilibrium. There's static equilibrium, where the object is at rest. So for example, these books are in static equilibrium, right? Because they're not moving, right? They're at rest. So all the forces that are acting on those books are balanced, okay? That's another way that we look at when we say the sum of the forces, right? We say that the forces are balanced, okay? Then the other state would be dynamic equilibrium, right? And that's when we move at a constant velocity. So from Unit 1, right, this is our constant velocity model. Okay, because the object is at rest, and remember, constant velocity, acceleration equals zero. All right, and then the second way that the first law is often looked at is the law of inertia. So inertia is the resistance to changes in motion. Okay, so the way I like to talk about inertia is like if you're at your house and you really don't want to do anything, your parents say, hey, we're going to go here. Well, you're going to have high inertia, right? Because you're going to resist that change to your motion, to your state very highly, because you don't want to do that. But then say we're going to go to your favorite restaurant, or we're going to go do something that you want to do. Well, and then you're going to have low inertia because you're going to get up. You're going to, there's not much resistance to that change in motion. So you're just going to go, right? The physical quantity associated with inertia, okay, is an object's mass. And the way we look at it is the measure of inertia, right? So large mass, big inertia. Small mass, low inertia, right? A large mass will resist changes to its motion greater than a low mass. Another way that we look at inertia is here with the example on the bus. So you got the person staring at their phone. Something happens which causes them to move forward because their body wants to stay in that position. And that's what's causing them to move forward because their motion or their inertia wants to stay right there. Okay. Um, so this is Newton's first law of motion. There's no real example problem here because, right now we've only looked at when the forces are balanced. So we're actually going to not look at his second law next. We're going to look at Newton's third law of motion because the second law is when we start getting into problems. Okay.